waste stuff, gash, refuse, call it what you like. It's getting rid of it that's the problem. In the past, it was useful for filling up old gravel pits and reclaiming wasteland. But wasteland's getting scarce, while the volume and variety of the rubbish we throw out gets even greater. It's not so bad in the country where you can still have a bonfire, and if you fancy, roast potatoes in it. But for cities with smokeless zones and neighbors to consider, it's a bit more difficult. There's pulverization, of course, and composting, or you can build an incinerator. Burning rubbish generates heat, and that can be just as useful as reclaimed land. They're building an incinerator in Nottingham. It's on a site down by the railway, about a mile out from the centre. When it's operational, this incinerator will solve the city's rubbish problem in a neat and tidy fashion. No smoke and very little waste. And at the same time, it will produce fuel for a big district heating scheme.
That's one of the superheaters being hoisted into position. To get them up, we needed a big crane.
The incinerator will have 2 lines to start with, but there's space for 2 more, and the building can be extended to take 6 lines altogether. Each crate is rated to burn 11.5 tons an hour, 24 hours a day. The beds are rocked automatically by hydraulic mechanisms to keep the rubbish mixed and burning evenly, and to stop clinker forming in the corners. The grates slope, and at the bottom, clinker and ash will drop into wet troughs. Hydraulic rams push it out of the wet troughs into the silo beyond. Residue is lifted from the silo by travelling crane and dropped through a grid onto a conveyor. However thorough the process of combustion, there's bound to be a certain amount of residue. In this case, it's mostly ash and unburnt metal. The conveyor passes under a large magnet, which will pick out ferrous metal and drop it down a chute. At the bottom of the chute, the metal will be pressed into bales and sold as scrap. Ash is carried on to another chute and will be collected and used to fill in old gravel pits. Heat generated by the burning rubbish heats water in the boilers. There are water tube walls enclosing the grates. Heated, the water in the boilers turns to steam. The steam rises and is channeled to the superheaters, where it will be dried and its temperature raised to nearly 300 degrees centigrade by the hot gases from the grates. This superheated steam is used for district heating. The gases, cooled, pass through electrostatic precipitators, where harmful elements like dust and grit will be eliminated before they're discharged into the chimney.
The chimney is 300 foot high. We got up in 25 days flat, pouring concrete round the clock.
The incinerator part, there have been a lot of changes in Nottingham, a lot of new developments. And this is fortunate, for it's meant that new buildings have been planned with district heating in mind. In fact, even during construction, heat was being distributed from temporary boilers that will be dismantled as soon as the incinerator is operational. Not more than a stone's throw from the city centre, streets of old and grimy terraced houses, often with a privy at the back, are being bulldozed like ninepins, knocked flat to the ground. Some people, born and bred in these old houses, deplore this wholesale destruction, but it does mean that the area can be replanned as a neighbourhood. And Here are no soaring inhuman tower blocks, but new houses planned for family groups. They are modern versions, really, of the familiar terraces. And when you want Nan to mind the baby, she'll still be just round the corner, not 10 stories up or down. The new houses will have central heating and constant hot water laid on, like the other services from underground mains. By the time the current building program is complete, there'll be some 6,500 corporation houses and flats on the district heating network. All in all, with older buildings like the Guildhall and the Council House, the corporation looks like being one of its own heating scheme's best customers. There will, of course, be other users besides the corporation and its tenants. Blocks of offices, flats, factories, and the 2 new covered shopping centres, where even in the vilest weather, one will be able to cock a snook at the elements for the price of a loaf of bread. Or just have a nice sit down in the warm and let the children work off their surplus energy.
The incinerator's output of superheated steam will be carried at high pressure in 14-inch mains, which are heavily lagged with calcium or magnesium silicate and covered in aluminium. The first leg of the pipeline follows the railway for about 1/4 of a mile, and then does a dog leg over it to get to the London Road heat station.
The heat station is, so to speak, the main warehouse or distributing centre for the heating scheme. It's a normal steam and electric generating plant with 3 coal-fired boilers. It's not new. In fact, the corporation bought it from Boots. But the whole plant is being completely overhauled and brought up to date by the National Coal Board. This is part of their contribution to the scheme, in which they and the corporation are partners with Pell Merck as consultants. There are 44 valves on each boiler, and every one has been taken out, cleaned, tested, and if necessary, replaced. Then turbines, feed pumps and mechanical stokers are all being overhauled by specialist firms.
In principle, steam from the incinerator will be used to carry the base load, while the coal-fired boilers at the heat station will meet fluctuations and supply a boost during peak periods. Having alternative boilers and 2 sources of fuel is also a valuable safeguard against breakdown at either plant. Whether it comes from the incinerator or the heat station's boilers, steam first passes through the turbines to generate electricity, which, if it had to be bought and paid for, would cost at least £100,000 a year.
There's a new building at the back of the heat station. They call it the pump house, though pumping water around the heating mains is only part of its function. It houses the heat exchangers, which turn the steam into hot water in much the same way as espresso coffee is made. Here too there are dump condensers for getting rid of excess steam without annoying the neighbours. And from here the 2 circuits of primary mains will start, one going north, the other to the south.
We had to get a bridge across a canal at the back of the heat station, and the only way to do it was to swing it down in sections from the railway.
Had to do the job on a Sunday too because of the canal traffic.
It wasn't all that difficult as a job. but there wasn't a lot of room to manoeuvre in.
Most of the sections went together pretty well, as they should have done. But there was only one that was out, by 1/8 of an inch. Gave us a nasty few minutes, that one did.
When you come to think of it, planning a route for a new set of mains through an old city is quite an undertaking, even on paper. Mains are big pipes, 16 inches in diameter even without lagging. And there are 2 of them, one flow and the other for return water. However they are laid, they are bound to need a fair amount of space.
Where mains are carried above ground, as they are when they leave the heat station and cross the canal, they are orthodox pipes which are lagged, waterproofed and screened. They carry water at a pressure of 185 pounds per square inch and a temperature of 140 degrees centigrade, well over normal boiling point.
On the whole, the canal is an advantage. It's an established route going more or less in the right direction, and the pipes can follow it. There are questions of way leave to be sorted out, but with the pipes above ground, the snags are at least visible.
Just down the road, there was a job that really was tricky. We had to take the top off an old brick sewer.
And it was right under a main road junction with traffic coming all ways.
According to the plans, there was room to push the heating pipes through between the top of the sewer and the road. But when we probed, we found that the old sewer was so close to the surface that the only thing to do was to slice the top off. We tried to find another way through, but there just wasn't anywhere else for the mains to go.
We was a 9 days wonder down that hole. Should have passed the hat round.
It was slow, because we had to be very careful not to let the rubble fall, or it would have blocked the sewer.
Job took 2 days, just as we had planned. And we were dead lucky it didn't rain. What with the stink down there, we'd enough troubles on our hands without a flood.
The city authorities wouldn't hear of their sewer being made smaller. So what we did was to replace the old brickwork with these concrete rings. Their inside measurements are the same as the sewers, but they're thinner than the old brickwork. This way we gain just enough space for the heating pipes without making the sewer any smaller inside.
The whole district heating network is admirably compact. From the heat station to the centre of the city isn't much more than 3/4 of a mile, and the far side of the housing estate on the northern circuit is less than a mile beyond that. Even so, there are a good 6 or 7 miles of primary mains in the northern circuit alone.
Underground, where ducts are impractical, the pipe-within-a-pipe system is used. These pipes are supplied in lengths already lagged, with the insulating material packed in the space between the inner and outer walls. Heating mains like this can expand by as much as 3 feet in 400 yards. To prevent this happening, expansion chambers, or above-ground expansion loops, with telescopic joints, are built into the circuit to absorb the movement. This prevents expansion exceeding 2 inches anywhere around the circuit.
Our Calvin's from the West Indies. Says he opted for welding because he thought it'd be a nice warm job. He reckons it takes about 4 hours to make a good job of one of these joints.
Joints are tested by ultrasonic or radiographic instruments which detect faulty welds and show up the rough edges of badly aligned pipes which could throw extra strain on the joints. The whole circuit is tested several times, section by section, to make sure that there are no leaks, and when the trenches are filled, a strip of yellow plastic is laid just above the mains as a warning to future excavators.
You can't dig a hole anywhere in Nottingham without running into the caves. The sandstone in which the city is built is riddled with them. Few have been properly surveyed, and dodging them is a nightmare for people laying pipelines. Sandstone has wonderful insulating properties, and Stone Age families who lived in the caves had no heating problems. The heat of their bodies was enough to keep the place warm. Later, lace makers used them. They needed an even temperature. There was even a flourishing underground tannery, and this, according to local law, was Samuel Hancock's drinking parlour. Even today, there's no better place for storing beer. The heating mains only just avoided Samuel Hancock's underground parlour. Just outside it, they make a right-angle turn, duck under the railway, and go up through a heading onto the embankment above. The tunnel ahead makes a good, straight, uncluttered run for the mains, and it's not used now, except for shunting. It's a real bonus, this tunnel, for up above the pipes would have had to twist and turn through half a mile of congested city streets and buildings. When it was built at the turn of the century, this tunnel was a major development, with the station, a £1 million project that enabled passengers to step off the train in the centre of Nottingham. Where the heating mains emerge in the sub-basement of the new Victoria Centre is just about where the platforms used to be. Today, it's an underground garage with parking for 2,000 cars. The centre is built on the site of the old station, and they've kept the station clock. Behind, in the tower blocks, are corporation flats designed for young people without families. The rest of Victoria is a private development, a multi-storey shopping centre half as long as Regent Street, where an umbrella would be as out of place as a mink coat on the equator. It's the biggest covered shopping area in Europe, until someone goes one better. The market traders moved here with some misgivings. Would they lose their customers? Would the poshed-up market lose its character? But it would seem that customers and traders have both survived the move. St. Anne's, which is just beyond the Victoria Centre, will be fed from the same circuit of primary mains. Although this whole area was cleared for rebuilding, it's not made it very much easier for the heating engineers. Many of the old mains and service pipes were just left in the ground, and on one short section of the heating circuit, it was 6 weeks before a satisfactory way could be found of fitting the new mains in amongst the old. For one thing, there's got to be at least 18 inches between heating and electricity mains.
Primary mains in housing areas like St. Anne's are orthodox pipes lagged with pre-formed calcium silicate and enclosed in waterproof concrete ducts. The primary circuit is linked to a secondary circuit which serves the houses by substations. In the substation, water from the primaries, which circulates at 140 degrees centigrade, is mixed with cooler return water from the secondary circuit to produce a secondary flow of 88 degrees centigrade. Pressure is regulated by constant and variable speed pumps. Heat consumption is measured by mechanical integrating type meters, which are read on a monthly or quarterly basis.
If you unwound all the secondary mains serving houses and schools and other buildings and strung them out in a line, they'd reach pretty well from Nottingham to London. Properly speaking, the district heating scheme's responsibility ends with the delivery of heat to the door, like gas and electricity or any of the other main services. Installations in buildings are up to the owner of the property. Some choose conventional hot water radiators, others warm air heating. Whichever it is, the heating agent is the hot water in the district heating mains, which simply transfers heat to the water or air in the customer's installation.
Several different types of piping are used in the secondary network. All are of pipe-within-pipe construction, with insulating material packed between the walls. Casings are made of PVC or glass-reinforced plastic. Two have pre-fitted sleeves that are shrunk into position over the joints. Inspection chambers and pressure-regulating valves are built into the circuit at intervals, and before the ducts are closed, joints are tested and every section of the run inspected.
Secondary pipes get progressively smaller the further they are from the substation, dividing and branching to serve different parts of the site. By the time they reach the houses, they are no more than a couple of inches in diameter.
Where the mains are connected to houses, a valve is built in to absorb fluctuations in pressure. Each house has normal thermostatic and manual controls so that the customer can adjust the temperature to suit his own needs. Consumption is measured by proportioning meters fitted to the radiators or to the hot air fans and to the hot water system. Tenants make fortnightly prepayments, which are adjusted at the end of the year when readings from individual houses are compared with the collective readings shown on the substation meters.
Of course, there are still some people who maintain that central heating is unhealthy, gives you colds, makes your head ache. Not so long ago, children and grown-ups accepted chilblains as inevitable. But just imagine this gymnasium without heating. There'd probably be icicles hanging from the ceiling. Totted up, Nottingham and the 4 neighbouring areas using the incinerator throw out 180,000 tonnes of rubbish a year. In terms of heat, this is worth something like 60,000 tonnes of coal. Even so, the incinerator's output of steam is not enough, for this district heating scheme is bigger than any other in the country, and some 40% of the total load is made up by the coal-fired boilers at the heat station. The scheme is being run by the National Coal Board through their agents, Associated Heat Services. Its operational centre is the heat station's new control room, which has been equipped to feed back information on heating conditions from all over the city. "99 different mimic displays illustrate design conditions for instant comparison with actual conditions. Information can be received and diagnosed at the rate of 1,000 signals every 3 minutes. It's automatically referred to a data bank, and if there's need for action, reported, so that when problems do occur, they are dealt with promptly. So here's a city that is not only getting rid of its rubbish in a very tidy fashion, but is making good use of it. To tackle a project that so radically affects the way we live needs guts and imagination. It needs capital too, and the technical know-how that only experts can provide. It's an enterprise jointly undertaken by the Corporation and the National Coal Board. And what it does for all who live in the city is surely well worthwhile.